to implementing graph neural networks, let's consider a very interesting and rather powerful use case of these structures, specifically the construction of knowledge graphs. Let's start off by looking at what exactly knowledge graphs are. Well, these represent a certain type of graph structure where there is an emphasis on contextual understanding of the entities, where entities are considered in terms of who exactly or what exactly they interact with. And to prevent such graphs from getting overly complex, there is an organizing principle which is usually set in place. While this may all seem a little abstract, what this boils down to in practice is that what may be considered the properties of each entity are usually modeled as separate nodes which are related to that entity. In just a moment, we will see exactly what this means, but keep in mind that knowledge graphs are typically stored within graph databases. So what could a knowledge graph look like? Well, here is an example of a social network which is modeled as such. Right in the middle here, we have a person who is related to a number of other persons, and then various details corresponding to the person, which could be modeled as properties, are in fact represented as nodes to which the person is connected. These include companies which the person has worked for, various skills which they possess, as well as the university they graduated from. If we were to fill in real values for each of these, this is what our knowledge graph might look like. Looking at the skills of this person, these include Python, Azure, Bash, and SQL, and a new skill will be modeled as a new node connected to this person. Now, let's consider how such a knowledge graph can be used in machine learning. For instance, given all of the other information present in this graph, is it possible for us to predict a specific skill which the person possesses? So given their connections, the companies they have worked at, as well as their other skills, can we make predictions in terms of skills that the person is likely to possess, but which they have not explicitly listed on their social network profile? Similarly, given all of the other information, could we also predict which companies they have worked at? And by extension, we could also try to predict individuals whom this person is likely to know, but is not connected to in the network. When it comes to machine learning algorithms, well, let's consider the fact that a specific skill, such as Java programming or the name of a company, may represent specific node labels. So to identify a skill or a company, well, these are values which need to be predicted. This, of course, represents a classification problem for a graph neural network. And to help make these predictions, all of the other connections of the person can be taken into account. That said, however, the convolution functions which we have explored so far, which involve simple